we're going to, like I said, we're going to just do a refresher on matrices. Matrices are one of those things that you can see on standardized tests, which is why we're doing it. Okay. We are simply going to add, subtract, and multiply these. These are all things that we did last year, but good refresher. Okay. What is a matrix? So it is defined as a rectangular array of numbers with m number of rows and n number of columns. There is something called the order of a matrix, which is also referred to as the dimensions. And it is the number of rows by the number of columns. And you literally leave it like written out like that. So if I am counting rows, which are the horizontal guys, there's 1, 2, 3 rows here. So this would be 3 by. And then if I am counting columns, which up and down, that is 2. So the dimensions of this matrix are 3 by 2, or the order of the matrix, because you'll see those used interchangeably, 3 by 2. Obviously not a test question, but that's important for when we get to like multiplying. You have to be able to identify your dimensions. All right, so the sum and difference of the matrices are what we're going to do first. For these, you literally just add and subtract the corresponding entries. So the first row, first column gets added to first row, first column. First row, second column gets added to first row, second column of the second one, just like that. It can only be done if the matrices have exactly the same dimensions. So you can only add a 2 by 3 to a 2 by 3. Okay, they don't have to both be 2 by 2 or 3 by 3. They don't have to be a square matrix, but they have to be the same. And I would say check for that first because it saves you a ton of work. If you can't do it and you start to do it, you've lost valuable time. If you can't do it from the beginning, you would say can't do it. And if it asks why, you would say the dimensions don't line up. So they'll look something like this, or they could look something like this. It says carry out each indicated operation or explain why it cannot be performed. So if I look at A, those are both 2 by 2s, which means it can be done. And I literally just add the cell for each one. So 2 plus 5 is 7. 3 plus -1 is 2. -4 plus 3 is, or sorry, -4 plus 7 is 3. And 6 plus 0 is 6. And then I put it back in my brackets to show that it's a matrix. Easy stuff, right? This is when your brain gets a break a little bit. All right. B, now it's subtracting. So it's a 2 by 2 and a 2 by 2. It can be done. And you could choose, like, if you want to distribute, because people make stupid mistakes when it's like minus a negative. So if you want to distribute that negative in, change all the signs of the second thing and put a plus between, you totally can. If not, you're doing -6 minus 7, so -13. You're doing -3 minus 10, so -13 again. You're doing 10 minus a -3, that becomes plus 13. And 4 minus 8 becomes -4. God bless you. Still good. Yep. Okay, go to C. Now what? It can't be done. This is a 3 or 2 by 3, and this is a 2 by 2. If you tried to do it, like you would add this one to this one, you would add this one to this one, and hopefully you would realize there's nothing to add that to. But before you even waste your time doing that work, you want to check. So this cannot be done. Different dimensions could be a reason. Or dimensions not the same, or order not the same, or something like that. On WebAssign, I think you put the word impossible in all capital letters. All right, then D, you're just doing 2 things. That's all. Okay, you can either like group these together, do those, and then subtract it, or you could seriously just do a compound. So I would do 2 plus 5, which is 7, minus 3, you get 4. Then I would do 3 plus a -1, that's 2, minus 1, that's 1. Then I would go to 4, -4 plus 7, that's 3, minus a -2 is plus 2, so that's 5. And 6 plus 0 is 6, minus 7 is -1. Questions on those? All right, a scalar product, okay, much like a vector with a scalar, is just a number that you would multiply on the front. So if I had something like 2 times this whole matrix, I would literally just multiply 2 into every cell that's inside the matrix. So the other way you'll see addition or subtraction problems is written like this. They will give you at the beginning, here's A, here's B, here's C for as many matrices as you need. And then it will give you commands like this. So 2A means literally take 2 and multiply it into A. A scalar multiple can always be done. So this would be 6, -2, 4, and 14. Then you go to B, 3B plus A. So before you do the scalar part, make sure you can do the addition part. Otherwise, you're going to waste your time doing the scalar and then not be able to do the second part. So because B and A are both 2 by 2s, this can be done. So then I would do 3B, so multiply the 3 in, I'd get 15, 30, -6, -3, and then add that to A. So 3, -1, 2, 7. And I'd get 15 plus 3, which is 18. 30 plus a -1, 29. -6 plus 2, -4. And -3 plus 7, 4. Good on that one. All right, then B minus 3A. Again, check to make sure it can be done. We already know it can be. B is going to stay as it is, 5, 10, -2, -1. And then you have 2 choices. Either distribute in a -3 and add the 2 matrices, or distribute in a +3 and then subtract. So I'm going to do the first way because we haven't done it yet. Like I'm going to actually distribute in a -3 and change this to a plus. So this becomes -9, +3, -6, -21. And then we can add. So -4, 13, -8, and -22. So again, you could have done it either way. I could have distributed in the -3 like I did and then add them, or I could distribute in a +3 and subtract them. I would actually recommend doing the -3 distributed in because that's where people make, like when you do minus negatives, that's where people make stupid mistakes in their head. Questions on these? Cake, right?
Yes.
Yeah. Okay, now we get to matrix multiplication, okay? So this is one of those processes that if you practice, it's easy and becomes second nature. If obviously you don't, this gets confusing. We don't multiply matrices by like multiplying the individual cells. Like I don't do cell 1 and cell 1 and cell 2 and cell, like that's not how we do it. What we do is we multiply across and down. So if you remember, you multiply the row of one matrix times the column of the other and you add the parts together. To see if it can be done, you check the dimensions of the original matrices. If let's say the first matrix is a 1 by 3 and the second one is a 3 by 1, they do not have to be the same dimensions to multiply, but the inner 2 numbers have to match. So the number of columns from the first guy has to match the number of rows from the second one. So the inner 2 have to match. If those match, then it can be done. And the outer 2 are what your result matrix is going to be. So if I had a 1 by 3 and a 3 by 2, it can be done because the 3's align. The 1 by 2 is going to be the dimensions of my answer, okay? So the first thing you want to do is check that. Can it be done? Once you know what the results of your multiplication will be, then for me, I set up a matrix that would be that dimension. So like, let's say I'm doing this one. Let's say it's a 1 by 3 and a 3 by 2. Then my answer is going to be 1 row with 2 columns. And then this cell is called row 1, column 1. This cell is called row 1, column 2. And the name of the cell tells you what 2 things you're multiplying together. So I'd be multiplying the numbers in row 1 of my first matrix times the numbers in column 1 of my second. So that's the across and down. And then I add those pairs together. Obviously, we're going to do examples with numbers, but that's the idea behind it, okay? So first thing, check, can it be done? Second thing, what are the dimensions of your answer? And then third thing, go through the process. So if I look at the example that's here, that's a 2 by 2 and a 2 by 2. The 2's match, so it can be done. The 2 by 2 is my answer. So then we made a matrix that has 2 rows and 2 columns. And then you multiply across and down. A times E plus B times G. And that goes in that first cell. And then I would move to the second one. And I would be multiplying row 1, column 2. So I go back to my original matrices. I multiply row 1 by column 2 in its pairs. So A times F plus B times H. And then I literally continue on through my matrix in that order. Do you remember this? Yes, a little bit? Okay. All right, so look at example 3. What are the dimensions of A? 2 by 3. What are the dimensions of B? 3 by 2. So can it be done? Yes. What are the dimensions of my answer? 2 by 2. So I'm literally going to make a box with 2 rows, 2 columns. And what is the name of that first cell? Row 1. Yes, cell 1, but what is it? Row 1, column 1. That tells you what things you're multiplying together. Row 1 from the first matrix, which was A, and column 1 from the second matrix, which is B. And I do it in pairs. So I'm going to do -2 times -4 plus 1 times 1 plus 3 times 2. God bless you. And I get 8 plus 1 plus 6, or 9 plus 6, which is 15. Then I go to my next cell, and that cell I'm going to the right, that has a name of what? Row 1, column 2. And that tells you that you're multiplying row 1 from the first guy. So it's already circled with column 2 from B. And again, we do it in pairs. So I do -2 times -1 plus 1 times 0 plus 3 times 3. And I get 2 plus 0 plus 9, which is 11. Still good? Now I go to the next cell. So bottom left is called what? Good. Row 2, column 1. So now I'm moving to row 2. And this is beautiful to do in Notability because you can highlight, move around. Remember, you're going to have to do it on paper next week. Okay, so keep that in mind. Row 2, column 1. So -1 times -4 plus 5 times 1 plus 0 times 2. And I get 4 plus 5 plus 0, which is 9. And then I go to my last cell, which is row 2, column 2. So still row 2 from A, but now it's column 2 from B. So -1 times -1 plus 5 times 0 plus 0 times 3. And I get 1 plus 0 plus 0, which is 1. Now, I know you're smart, but half of you are also lazy. So be careful and don't try to do all that in your head. Like on the homework, maybe try it and see if you get it right. Sure. But like on your test, be careful and write it out. It would suck to get it wrong because you like multiplied the 0 and put a different number. Like those are the little things that people make mistakes on. Okay, so now is A times B the same as B times A? No, order is important here because if I switch it, now I'm multiplying the rows of B times the columns of A. So for me, like because my brain is trained so left, right, I literally have to rewrite that order. I can't go here and then here. Like it throws me completely off. If you can, sure, do it. I don't care. But for me, I literally have to rewrite A to the right of B. So negative 2, 1, 3, negative 1, 5, 0. Now I'm looking at these two. What are the dimensions of B? 3 by 2. What are the dimensions of A? 2 by 3. Can it be done? Yes. What's the answer going to be? A 3 by 3. So what's it, like a tic-tac-toe board? Which appears to be more work, but you only have to multiply 2 pairs each time, so it's not as bad. All right, so now we're going row from B, column from A. So row 1, column A would be negative 4 times 2, negative 2, plus negative 1 times negative 1, and I get 8 plus 1, which is 9. Then I go still row 1, but I do column 2, negative 4 times 1, plus negative 1 times 5, negative 4 minus 5, negative 9. Then I go row 1, column 3, negative 4 times 3, plus negative 1 times 0, negative 12 plus 0, negative 12. All right, you finish it out. See what you get. Go with row 2. All right, so row 2 should have been negative 2, 1, 3, and row 3, negative 7, 17, and 6. We good? Yes? Okay. All right, we'll just set up the next one. I think you're okay. So find the product could also be just written like that, okay? Up against each other where it doesn't give you letters. So what are the dimensions of the first one? 4 by 2. The second one? 2 by 2. So can it be done? Yes, and the dimensions would be a 4 by 2. Are you okay? Do I need to work through it? Work okay, right? Okay, so when you get to the web assign tonight, you'll see it look like this. So just a heads up, okay? When you look at these answers, like notice these little green arrows pointing in all directions. Those will expand or condense your matrix rows and columns. So let's say my answer is going to be a 2 by 2. I would leave it like that. But if my answer is going to be a 2 by 3, I would have to extend it, right? So 2 by 3, 2 rows, 3 columns, I would extend it out. If it was only a 1 by 2, I'd have to shrink it down. So you use those little green arrows to do that, okay? If it's impossible, you literally put the word impossible in all capital letters. It says in any of the cells. So you could put it in any of the cells, and if it's right, it will mark it right. You don't have to put it in all of them. Yeah.
I tried that and I got it wrong.
The impossible?